In this video, I will describe to you the photoelectric effect. So, photoelectric effect. And as we're talking about quantum mechanics, the last two videos were about quantum mechanics, I will relate what Einstein found to our knowledge from the previous videos. So the photoelectric effect is a little bit more complicated than what I will explain, but I want to keep it simple, so I won't explain all its details. There's basically two things you should know about it. The first thing he found was that electron ejection does not depend on light intensity. So electron ejection does not depend on light intensity. So from this, he was able to derive an equation to pretty much explain the photoelectric effect. And what he found was the kinetic energy of the ejector electron. So I'm going to write it as EK, so kinetic energy, and this is of the ejected electrons. And the equation was H times V incident. The last factor is what we call a work function. So it's something like this. So let me explain each factor of the equation. We have first our kinetic energy is equal to HV incident minus our work function. So I already said the first thing is the kinetic energy. And that is the kinetic energy of the ejected electrons. And well, it's going to be in joules because it's simply energy. Then we have our H, and if you recall from the previous video, it's Planck's constant. So just to refresh your mind, it's 6.62 times 10 to the negative 34 joules times seconds. So that's our units there. That's Planck's constant. Then we have our V incident. That is our frequency, or the frequency of the incident. That is in hertz, or 1/2. And finally, the work function. So work function. And I want to talk a little bit more about the work function because it's really important. So let's talk about a work function. The work function is the minimum energy required to remove an electron from metal. So that just relates to the photoelectric effect experiment. But from this, what really you should know is that it's minimum energy required to remove the electron, of course. So it's going to be in electron volts, and that is it's kind of like joules. So it's going to be 1 electron volt, which is the unit of the work function. And if you want to transform it into joules, it's convert it into joules, it's 1.6 times 10 to the negative 19 joules. And if you don't have it, you can determine it from multiplying Planck's constant to the initial frequency, or what is also called the threshold frequency, which is just the minimum frequency required to eject electrons. So kind of like this concept. Instead of minimum energy, minimum frequency. That is threshold frequency. And now let's actually apply all of this combined with Planck's equation and our wavelength and frequency equations to actually solve a problem. And one thing you should know before we start solving problems, whenever if you want to solve for the kinetic energy, which is what we're solving for in the photoelectric effect, you can substitute it by its regular equation, half mv squared, and this v is velocity, not frequency, and the m is just mass. That is the regular kinetic energy equation. So now let's actually solve a problem. So what is the velocity? So our initial question is velocity. I'm going to write it as a big V of an electron, and they tell us that the mass of the electron is 9.1 times 10 to the negative 31 kilograms, emitted by, let's say, lithium. So we have a work function of 2.9 electron volts. Okay. So what is the velocity of an electron emitted by lithium if light of frequency 4. So they're telling us the frequency. I'm going to write frequency with an F just so you don't confuse it with velocity. So they're telling us the frequency is 4.77 times 10 to the 15 1 over second. So emitted by lithium if light of frequency is absorbed. Of frequency 4.7, of course. So we have all of our data. Let's use everything we know to solve this problem. So as I've always told you, the first thing you always want to check is the units. If you have the wrong units, you will get the wrong answer every time. So we have 1 over second for frequency, so that's good. We have a mass in kilograms, and because we're working with energy, that is joules, it will be in kilograms too, so that's good. But our work function is in electron volts, and I told you that 1 electron volt is 1.6 times 10 to the negative 19 joules. So let's convert that. That is, so you solve it by multiplying 2.9 electron volts times 1.6 times 10 to the negative 19 joules, and that will give you 4.64 times 10 to the negative 19 joules. So all of our units are right now. And let's write our equations. Planck's equations was energy is equal to Planck's constant time frequency. And the equation we just figured out from the photoelectric effect is kinetic energy is equal to hv minus the work function. And when you look at what they're asking, velocity, we don't have velocity in any of them, and I'm sorry, I told you that I was going to write frequency as an F, so there we go. We don't have velocity in any of them, but I told you that kinetic energy can be changed to half mv squared. So now, and this v actually represents velocity. Let me fix it. So we have 3 equations. Let's get one complete equation. So let's put this in here and this in here, because I mean these two are the same, they're equal, and the kinetic energy is going to be that. So let me write it as this. Half mv squared, that's our kinetic energy here, is equal to energy by changing the hf to e, that's this, this thing, minus the work function, which was the last factor here. It looks a little bit messy, but now we have all we want. Let me go to the following page. So half mv squared is equal to e minus our work function. So let's solve for what we want. V squared will be equal to 2 times e minus work function over mass. So v will be square root of all of that. And just by solving for that, you can obtain the velocity. Let me do that. So we said that our energy we haven't gotten. So let's do that really quickly. That's HF. Energy will be Planck's constant times the frequency. So 6.62 times 10 to the negative 34 joules times second times frequency was 4.77 times 10 to the negative 15 1 over second. So our energy is 3.15 times 10 to the negative 40 times 10 to the negative 18, sorry, joules. So we have this now. We can plug it in here. So 3.15 times 10 to the negative 18 joule minus the work function was 4.64 times 10 to the negative 19 joule. 4.64 times 10 to the negative 19 joule. Okay. Over the mass, which was 9.1. Yeah, 9.1 times 10 to the negative 31 kilograms. And that should be equal to velocity equals to 2.43 times 10 to the 6 meters per second. So it's a very high velocity, and that is usual of an electron. So that's our answer. And it's a really good practice to use all of the equations you've learned, like Planck's equation and the regular wavelength equations. You have to use them all in some problems. So that's good. And that's it for the photoelectric effect.